Hello dear students, in this video I am going to discuss about transport services available to applications. Many networks including the internet provide more than one transport layer protocol. When we develop an application, we must choose one of the available transport layer protocols. Then how do we make this choice? We pick the protocol with the services that best matches our applications needed. We broadly classify the possible services that a transport layer protocol can offer. They are reliable data transfer, second one throughput, timing, and security. First one, reliable data transfer. Packets can get lost within a computer network. For example, a packet can overflow a buffer in a router or can be discarded by a host or router after having some of its bits corrupted. For many applications such as email, file transfer, a data loss can have devastating consequences. Thus, to support these applications, something has to be done to guarantee that the data sent by one end of the application is delivered correctly and completely to the other end of the application. If a protocol provides such a guaranteed data delivery services, it is said to provide reliable data transfer. Next one is throughput. So, what is throughput? To define throughput, consider transferring a large file from a host A to host B across a computer network. This transfer might be a large video clip from one peer to another in a peer-to-peer file sharing system. The instantaneous throughput at any instant of time is the rate in bits per second at which host B is receiving the file. Okay. A transport layer protocol could provide guaranteed available throughput at some specified rate. With such a service, the application could request a guaranteed throughput of R bits per second. And the transport protocol would then ensure that the available throughput is always at least R bits per second. Such a guaranteed throughput service would appeal to many applications. For example, if an internet telephony application encodes voice at 32 kilobits per second, it needs to send data into the network and have data delivered to the receiving application at this rate, that is 32 kilobits per second. If the transport protocol cannot provide this throughput, the application would need to encode at a lower rate and receive throughput to sustain this lower coding rate, or may have to give up. Applications that have throughput requirements are said to be bandwidth sensitive applications. Many current multimedia applications are bandwidth sensitive. Although some multimedia applications may use adaptive coding techniques to encode digitized voice or video at a rate that matches the currently available throughput. Next, timing. A transport layer protocol can also provide timing guarantees. As with throughput guarantees, timing guarantees can come in many shapes and forms. An example guarantee might be that every bit that the sender pumps into the socket arrives at the receiver's socket no more than 100 millisecond later. Such a service would be appealing to interactive real-time applications such as internet telephony, virtual environments, etc. All of which require tight timing constraint on data delivery in order to be effective. Long delays in internet telephony tend to result in unnatural pauses in the conversation. For a non real time applications, lower delay is always preferable to higher delay, but no tight constraint is placed on the end to end delays. Next one is security. A transport protocol can provide an application with one or more security services. Example, in the sending host, a transport protocol can encrypt all data transmitted by the sending process, and in the receiving host, the transport layer protocol can decrypt the data before delivering the data to the receiving process. Such a service would provide a confidentiality between the two processes. A transport protocol can also provide other security services in addition to the confidentiality, including data integrity and endpoint authentication. Thank you.